Starting the stream. Did you get all of your housework completed?
Oh, I'm still in the process of cleaning this house. This house is big.
I know it
We
is a
love
very
our
big.
house. We live in the middle of nowhere, so we bought a house for the same price we would have bought a 1,000 square foot condo in Boston, which it turns out in Illinois is a house bigger than you can clean in one day.
And there's like a conveyor belt of packages from Amazon.com showing up at your front door.
We're working to get better at that
Yeah, yeah. I just did.
slowly.
Well, it's good. What is it? Black Friday today. So I hit Amazon pretty hard today. But I got a bunch. I got all my Christmas shopping done, so I feel good.
See, I'm gonna try and do my Christmas shopping, and I usually do this. I try and buy all my Christmas gifts on Etsy from the actual artists. This year, I
Aw,
think I'm gonna try under Redbubble as well because they just have cool shirts. But
that's a cool idea.
I can't make handmade things, but I can buy other people's handmade things.
Yeah, no, I think that's a great idea. Um, oh, we're live, by the way. Hey everybody. So I'm gonna say
Hi.
hello to you all, and I'm gonna give you adequate warning now. So if you're in the chat on YouTube, just say hi, say hello, good day, something like that. How's it going, eh? And then I will say hello to you in about a minute. Um,
And hey, there's a geomagnetic storm going on.
I know.
So if you're in the right places and it's dark, go out and look up.
Check it out. Check it out. Whoa, my phone is freaking out. Here. So I use Aurora Alert,
Mm,
which there we go.
cool.
Yeah. So that's my view right now. And so orange, whenever it hits orange, that is visible in the sky off to the horizon. If we get above 4.67, then we can see it kind of in the sky.
Yeah,
So
you're a lot further north than I am, and that's a glorious thing. And
yeah,
yeah,
yeah. So if you can see at the top there, it says Aurora needed for KP needed for Aurora is 5.67. So we needed 5.67 to get an Aurora. But we can see it on the horizon anywhere around 4 and even a little
that's
lower. And which is great. So Carla, my wife had never seen an Aurora before. She's of course from Texas, and so you have to be very powerful geomagnetic storm to get it visible down there. And so this was like one of the things she really wanted to do was see an aurora. So I got this app installed on the phone, and we waited for a night that it was shrieking at us that there was an aurora happening. We went out to a nice place with a good dark skies visible to the north, and we were able to see it. In fact, what happened actually was Chad wanted to see an aurora too. Chad's of course the cameraman. He's our editor on Astronomy Cast now. And he wanted to see an aurora too, and so I said, "Oh yeah, it looks like there should be an aurora on the horizon tonight." And then I went to bed, and, and then the next day he was like, "Yeah, I went out and I took a bunch of pictures and showed us, and absolutely his camera picked up these beautiful auroras off to the horizon." And so we learned that when it says that there probably are auroras, there probably are auroras.
yeah.
Like, go out and take some pictures. So we learned a terrible lesson, and we went out a couple of months ago and got some great shots. It's been raining literally nonstop since then, so we haven't had a chance to go out and see it.
Yeah, we've been just like gloriously cloudy and miserable. A little sarcasm there.
Gloriously. I'm going to say hi to Carolyn B., Dane Coview, Douglas Fry, Dusty Reichwin, Eric Knapp, Giselle Sabrin, Greg Nickel, Guido Bibra, Hugo Burnham, John Suffolk, Larry Beckham, Michael Collins, Michael Jobin, Michael Meyer, Michelle Lemay, MNB098, MNB, Nichols of the Yard, Ole Jorgen Nordhagen, Phil Wilcox, Robert Scott Herrick, Rio San, Sergio Botera, Seth Cooper, Sylvan Westby, Steve Heistand, Valdegast, William Van de Beek, the WSH crew, and Zap Van Zap Van. Hi, everybody.
Hi.
Is it raining men? Yeah.
No, it's not.
Cats and dogs. We haven't gotten to men yet, but we're at cats and dogs right now. No, so in November, our traditional average rainfall, we hit that by November 5th.
Dang.
Yeah. And it has been just continuing to just deluge. In October, we had 28 days of rain out of 31, which is a record. And I don't know what November is so far, but it's just awful. It's madness. So anyway, but we're off to Costa Rica in a couple of weeks, so I'm pretty excited.
Excellent.
Yeah, and I'm off to Toronto on Sunday to participate in the YouTube Next Up Canada.
Go Canada.
Go Canada. So this is the first time we've done this. So I get to go to the YouTube studio, use a bunch of their pro gear, take a bunch of lessons on how to use fancy cameras and editing equipment, and then we get to go on a shopping spree. So, Colin Jones, you can tell it's raining cats and dogs when you step in a poodle.
I love that. I was actually typing that one for how hilarious it was.
And Valdegas is saying that in Norway they specifically mentioned if it hasn't rained in Bergen, which is awesome. They should do that here. Weather forecast, like it should be like on Canada-wide news. By the way, it's not raining in British Columbia.
Yeah, Kyle and I periodically and at increasing frequency discuss moving to Canada because my husband's Canadian, and I'm like, we should move to Vancouver Island, and he's like, no.
It's fine. It's lovely.
He wants to move to maybe Kelowna. So.
Let's see if I can. Oh, my dog is freaking out here. Let's see. I'm gonna grab my camera here for 1 second. This is gonna wreck everything. Let's see. Can you see that? Yeah, there you go. That is my. You can't see it, Pamela, but everyone else can see it. That is my. That is what I've got going on outside. All right, we're gonna get professional. We're gonna do an episode of Astronomy Cast in theory.
And I am going to apologize to everyone who's watching it live for the whole wet hair thing going on.
Oh, don't. Oh, no.
I'm not going to go into details. I saved that for you and your wife. I had a dog that you shouldn't feed pig ears to, and the dog is clean, and then I required a cleaning. So, yeah, that's what this is.
Ew. Okay. All right. So we'll take, I've got a double slot graphic card just laying around. It's a bad video card. It died on me, and I had to downgrade again. Bad card. It was an expensive card, too.
The video setup I want is, have you ever been on a chat with Sylvan Westby? He has like the most.
Oh yeah. He's got a
Sony.
A7.
I want to figure out how to do that with my Canon because
you can. Yeah.
I just haven't yet. It's a goal. We should all have goals.
Lit goals.
We should record.
Yeah. Oh, and one other thing. People mentioned that my microphone has been blurping in the middle of our recordings. And I think I figured out what the problem was. Apparently, if you use a blue microphone and a Logitech 920 camera, when you are in online OBS, you need to set the camera's output to MPEG, not its default, and that stops the audio squeaking that's been happening. So
that is the most insane combination of issues.
Yeah. Have I ever mentioned how much I hate computers? How long that took me to get to the bottom of. So anyway, please let me know if you hear that audio squeal again, because I hope that by solving this problem, I made that go away. Okay. I'm going to press record.
Okay. I am pressing, and it gave me an error. Why are you doing this to me, electronics? Okay. Restarting Audacity.
Did we already mention computers suck?
Grumble.
I'm recording.
I'm rebooting Audacity.
I'm going to stop my recording then until you.
Okay, I think I'm back. I'm pressing record. It didn't give me an error box alert this time. Okay.
Right on. Okay. Here we go. Astronomy Cast, episode 430, Getting to and from Mars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
I am doing great. It's wet here. I'm really looking forward to summer again, but apart from that, things are going great.
It's kind of wet and gross here as well, but that's kind of just the way things are.
And for those of you listening, it is, of course, the day after Thanksgiving. This is the day we're recording it anyway. I have no idea. Did you have a good Thanksgiving?
We are very focused on cleaning the house around here. So being a Canadian and someone who knows far too much American history, Thanksgiving has become a day for cleaning.
Cleansgiving, yeah. All right, so we're going to continue our Mars journey. So landing on the surface of Mars is very difficult. In fact, it's probably the toughest planet to land on in the whole solar system. Today we're going to talk about what it's going to take to get to and from the red planet. All right, so let's set the stage here. We've talked a bit about what it's going to take to live on Mars, but the reality is that getting to and from Mars is borderline suicidal, right? When you think about, I just did a video about this, that we're at 53% success rate sending spacecraft to Mars. That's it. That half of the pathetic intelligent space metal you send at Mars is going to die. And so far it's only been space metal, but
Imagine the kind of memorials there's going to be someday. There's going to be here's the happy place where opportunity came to rest. Here is the sandpit of death where spirit came to rest.
Right.
And there's all the varying forms of crumpled, destroyed, embedded in the soil, and everything in between scattered across the surface.
Yeah, we've got sort of the Schiaparelli 2 crater on the surface of Mars. So needless to say, landing on Mars is a very dangerous thing. So let's kind of roll the tape backwards here. What does it take to get to Mars?
So I'm just going to lay out as a ground rule. We acknowledge there are issues with radiation. We don't know how to solve them. We're going to assume that someone wiser or at least more imaginative than you and I has solved this problem before we attempt to send humans to Mars.
Right. It's very safe. It's very safe in our imagination now.
So we're going to ignore the radiation problem.
Yeah.
Okay, so ignoring the radiation problem that we don't know how to solve, the first problem is you have to get out of the gravity well of the planet Earth.
And it's big.
It's big.
Yep.
You need more than 10 kilometers per second. And the reason I'm framing it that way is you can sort of imagine you launch part of your spacecraft to low Earth orbit, you launch more of your spacecraft to low Earth orbit, you join the humans with the spacecraft in low Earth orbit, and then you escape low Earth orbit.
10 kilometers per second, that's about 28,000 kilometers per hour, which requires a bomb that you sit on top of and it explodes a little more slowly than a bomb might normally. The point being, it's a lot of energy to break free of the Earth's gravity.
So once you're in low Earth orbit, you need to get yourself going about 4.3 kilometers per second to get from low Earth orbit, which is where the ISS is, where we currently are very skilled at putting human beings. So add in a delta V, a change in velocity of 4.3 kilometers per second. And now you can be on your way to Mars via a Holman transfer orbit.
Right. So you've taken your low Earth orbit, you're 10 kilometers per second. You then fire your thrusters an additional, what was it, 4.3?
It's 4.3.
Right. So now you've made a transfer orbit, and now you do this great long, slow adjustment. So you essentially are raising your orbit to the point that it eventually intersects the orbit of Mars.
So the whole idea is orbits are ellipses, and a circle is a very special kind of ellipse that happens to be the same radius everywhere you look. Most of the time, an ellipse is closer to the main body, so the sun on one side, further away on the other. And in this particular scenario, what we're looking at is Earth is the closest point to the sun on this orbit. Mars is the furthest point from the sun on the orbit. And you time things just right so that when you leave Earth and get all the way out to Mars orbit, Mars happens to be at just the right place in its orbit so that you intercept Mars.
Right.
If you screw up, there's no planet there. Mission's kind of a dud.
Okay. And that's not the hardest part. The hardest part is what you do when you get to Mars.
So with a Holman transfer, there's two different things that you have to do. First, you have to adjust your velocity to get away from the planet Earth. So here you're accelerating things to put yourself out further from the sun than the Earth's orbit when you get to the other side of the sun. Now, once you're there, you have to match Mars orbit. So you need to adjust your velocity again. So this is the Mars transfer orbit. And here we're looking at about 9 kilometers per second for getting yourself in orbit around Mars. Sorry, 0.9 kilometers per second. And that's not too bad in the grand scheme of things, but now you're just orbiting Mars. And orbiting Mars is all well and good, but we have this deadly idea that we want to put humans on the surface of Mars. Now, putting them on the surface of like Phobos or Deimos, really good, really easy. You're looking at way less than a kilometer per second delta V, nice friendly surface. You weigh like a few hundred sheets of paper. It's all good. Surface of Mars, we're looking at probable death.
Right. So you just mentioned sort of one way to go about it, right? Which is that you arrive at Mars on a trajectory that allows you to then fire your thrusters and end up in some kind of elliptical or eventually circular orbit going around Mars. The other option is go for broke and just enter the atmosphere in one fell swoop and aerobrake and then the rest.
That's a way to do it.
Yeah. Well, that's what that's what Curiosity did. That's what the Mars rovers did. Was they just entered directly, right along their Hohmann transfer. Their Hohmann transfer just intercepted Mars, and they did successfully land. I have a dog whining in the background.
We're sorry, Chad. It sounds like a squeaky toy.
I'm gonna eject a dog here. Give me 1 second.
Okay. This is the episode that has dog interruptions. And here's where I sit and fill dead air yet again, hoping that Chad catches this to remove it because
a dog got left out of the pack.
Okay.
All right, Chad. Do you want to just pick up from where I said what I said? Do you want me to say it again?
Say it again.
All right. So you've got this situation where you can just make if your path just crosses Mars. Curiosity did this. The Spirit and Opportunity did this. They just make a direct transfer, aerobrake, and then all of the rest of the things that you have to do to then make it to the surface of Mars, which is very dangerous.
So I have to admit, one of the reasons I'm a little bit reticent to consider that kind of a future is think about what the Apollo astronauts did, because they wanted to go home, and we're starting from the premise of they want to come home. It's a good premise, I think. The idea of leaving the bulk of your spacecraft on orbit, admittedly, this isn't what Elon Musk is looking to do, but as a nice, safe starting point, have the bulk of your spacecraft with all of the assembly that you need so that you have a nice, happy return. Leave that in orbit. And then have a lander that goes down and has the ability to come back up and, like the Apollo missions, dock, but let's not leave someone on orbit this time, dock up and then return. So this is where I'm thinking, put something in orbit, then land, rather than the go for broke aerobraking straight to the surface.
If I understand correctly, though, the go for broke arrow braking is the plan for SpaceX, for the interplanetary transport system. They are gonna, the shape of the spacecraft is going to act as a bit of an aero brake as it's coming in.
And this is where I have to admit that I'm a bit more cautious. I'm fully willing to embrace my NASA trained, overly cautious about lots of things kind of way of thinking. This show is not brought to you by NASA. I simply have lots of listening to safety things running through my head. So what Elon Musk is currently looking to do is you have your spaceship, you go to Mars, land on Mars, but first retro rocket. This is a lot like how they're landing on barges, how they're landing at Cape Canaveral. This is like the cool Jetsons technology that I kind of thought would never happen, and Elon Musk has made it happen. And the thought is that while you need the big booster rocket to get off the surface of the Earth, Mars with its lower gravity, you don't need that booster rocket to get off the surface of Mars. So what Elon Musk is proposing, hoping to do, go to Mars, use various chemical elements, hopefully fairly readily abundant on the surface, create fuel, use the fuel to then take off on that rocket that you have safely landed and not had any leg failures. It has always done leg day. Yeah. And then make it all the way back to Earth.
Right. Now the problem with the Martian atmosphere, of course, is that it's too thick, that you can't just do what they did with the moon, where you bring in, you get closer and closer to the surface, and then you fire your retro rockets, and now you're going directly down, and then you land gently on the surface of Mars. But it's too thin, so you can't do the aero braking like on Earth. You just enter the Earth's atmosphere, open up your parachute, and you can land nice and safely and gently. So they don't have that on Mars at all. You've got to do this crazy combination, and up until this point with NASA, they used this collection of methods. They would aero brake for a little bit with a heat shell. They would then fire a parachute that would bring it down from supersonic velocities. Then they would fire a retro thruster, and then in case of Curiosity, they had the sky crane. In the case of Spirit and Opportunity, they had that wonderful beach ball that bounced across the surface. So, but the problem is that really tops out at like what they've got with Curiosity. You can't go much bigger with that methodology. And so the SpaceX way is they're just going to bring that thing in screaming hot, and then it's going to turn, face the ground with its thrusters, and fire its powerful Super Draco thrusters and try to land gently. Let's hope it works. We're going to find out in 2018. So we'll know soon if this is going to work.
One of my big concerns about this, and here I have to fact check the last episode. I goof 6s and 9s. It's a thing I do. And in our last episode, I said that it's a 6-month trip to Mars. No, 9-month trip to Mars. Optimistic flipping of digits. It's a 9-month trip to Mars. Then you have to hang out and wait for Earth and Mars to get themselves aligned correctly to do the same Holman transfer orbit back. You're looking at a whole lot of time in whatever sized vessel you take with you. And with Elon Musk's plan, you're kind of trapped in a tiny space.
He said it sounds like fun. And you'll float around and you'll watch movies and you'll visit the restaurant, and it should be a lot of fun.
Restaurant?
Yeah, and it's gonna have 100 people on board. It's gonna be a hoot. All right, so we've talked about the thing landing, and we're going to talk about the long-term survival in space and how we're all going to get space madness. But I just want to talk a little bit more about the physics before we move on to, us going crazy.
You and I have been on cruises. This sounds like such a horrible idea to me.
It's an adventure. It should be a lot of fun. So we've got this rocket sitting on the it's landed safely. It's gone through the most dangerous part of this whole mission. It's landed safely on the surface of Mars. In the idea of NASA and SpaceX, it's going to refuel based on local elements.
So we're looking at a couple of different ways that you can do this. There's lots of carbon dioxide, water, all of these normal happy gases that we have here on Earth that it turns out you can make fuel out of. So one of the ideas is you can do a monopropellant in the form of hydrogen peroxide. This is actually something that was used in some of the earliest rockets. It's not the best propulsion system, but it totally works. The other idea is a little bit more complex, and this is you can create methane on the surface through a variety of different chemical reactions. So H2O, break it out into oxygen and molecular hydrogen. Breathe for a while, and this is what we're doing on the International Space Station right now. So breathe for a while, and then you end up as a human being creating CO2. You still have that 2H2O. You now have some more 2H2O. Sorry, not H2O. You have 2H2. You have molecular hydrogen. This chemical reaction will lead to water and methane. Methane is a fuel again. So as part of the normal respiration system, we can be taking that water, transferring it into the oxygen we need, respirating it into the CO2 that we then need to make methane. On the ISS, they just eject the methane. This is part of creating a closed system for the most part. It used to be we had to constantly take water to the ISS. Now we just take up hydrogen periodically. So we're looking to create methane.
Yeah, and this is one of the advantages of the system that SpaceX has proposed, is this idea of using methane as a fuel. It's sort of like the I remember watching the SpaceX presentation. It's sort of like the perfect fuel for what you could create on the surface of Mars. It's possible to make from the local elements. It's safer and easier to store than, for example, liquid hydrogen and liquid oxygen, which are traditional rocket launch fuels here on Earth. It's sort of like the perfect fuel to build, and in theory it should be easy to make. So let's say you've set up this rocket factory. It's landed on the surface of Mars. It has, it's brought in the raw ingredients. It has filled its fuel tank with methane, and somebody who is one of these colonists on Mars has decided, you know what, I want to come home again, please. What happens?
Well, you fuel your tank up and you hope that you landed level enough that taking off doesn't cause bad things to happen.
All right, let's assume that bad things didn't happen. How much? Now, we talked about Earth, that you need about 10 kilometers per second of velocity to reach escape velocity. What is the escape velocity on Mars?
So on Mars, you're just looking at 5 kilometers per second. And so it's less than half. So if you wanted to go from surface of Earth straight away, you're launching the whole darn thing at once, you have an 11.2 kilometers per second. I recommended you instead go to low Earth orbit. But if you just want to say, I'm done with this place, I'm below in this joint,
Yep.
It's 11.2 kilometers per second. From Mars, 5 kilometers per second. Mars, you also don't have the same issues with atmospheric drag that you have to overcome because the atmosphere is trying to slow you down while you're trying to get out. All in all, getting off the surface of Mars, if you have the fuel and if everything goes right, should be way easier than getting off the surface of Earth. But here on Earth, we have like Kennedy or Wallops, right, or any of these other launch facilities.
Yeah, you got that boulder field that you landed in on Mars.
Yeah. So
but I was